The role of artificial intelligence in revolutionizing shipbuilding. It's going to be given by Rodrigo Perez Fernandez, who I think a lot of people online do know. Just a little bit about Rodrigo, for those of you that don't know him. Rodrigo holds both a PhD and an MSc in Naval Architecture and Marine Engineering. He has also completed an MBA and several postgraduate programs in shipbuilding, maritime transport, and executive management. He is currently a Senior Director for Software Engineering at Siemens Digital Industries Software. He previously worked at Siemens as Global Portfolio Development Director, and prior to Siemens, he worked for 16 years at Senna, where he held roles of growing responsibility, working in multiple projects around the globe. Combining his activity in the industry, he is a professor in the Marine Engineering School of the Universidad Politécnica de Madrid, UPM. University of Madrid, I always call it, Rodrigo. So excuse my pronunciation. Where he lectures in gas and steam turbines and shipbuilding history, as well as other subjects. He's a member of the Committee on Education and Engineering, a member of the World Federation of Engineering Organizations, a council member of the Royal Institute of Naval Architects, and president of the Madrid branch of the Spanish Association of Marine Engineers. So Rodrigo will give his presentation and we'll respond to any questions, queries at the end. So I will hand the floor over to you, Rodrigo, and we look forward to your presentation as you delivered to us at RINA London branch, many very informative presentations in the past. So all yours.
Thank you. Ladies and gentlemen, it's a great honor and privilege to stay tonight in this RINA lecture. I would like to thank you, the RINA London branch, and his president, Keith Lilly, for inviting me to introduce you, some ideas about artificial intelligence and how this new technology can impact the mining industry. I will try to provide a state-of-the-art vision of the technology and a few cases which this engineering science can be useful in our sector. I will finish analyzing if we should fear this fourth industrial revolution enabling technology. I would like to start with a bit of the history, and in order to understand or to be able to understand how the artificial intelligence or digitalization has become today's buzzword, it's important to look at their predecessor that might give us a perspective of how this fourth industrial revolution, some people call now fifth industrial revolution, is in particular different. Probably all of you know that the first industrial revolution was born when humans started introducing machines into production by the end of the 18th century. This include going from manual production to the use of steam power engines and the water as a source of power. The second industrial revolution dates between 1870 and 1914, and also some of its characteristics date back to the 1850 and introduce pre-existing systems such as telegraph, railroads into industry. Perhaps the defining characteristic of that period, or during this second industrial revolution, was the introduction of mass production as a primary means to production in general. The third industrial revolution is much more familiar to us than the rest, as most people living today with industry leaning on digital technologies into production. However, the third industrial revolution is dated between the 1950s and 1970. It is often referred as the digital revolution and came about the change from analogical and mechanical systems into digital ones. Others call it the information age too. So this third industrial revolution was and still is a direct result of the huge development in computer science and communication technology. I have added a photo of a person crucial for the development of the CAD systems. He was Pierre Bessier, a French engineer working at the Arts and Métiers Paris Tech. After his mathematical work concerning surfaces, he developed a pioneering surface CAD/CAM system named Unisurf to easy the design of parts and tools for the automotive industry. A bit later, in the 1960s, specific software tools for shipbuilding as AutoCon or Foran were coined, becoming the working basis for the following generation of shipbuilding CAD/CAM systems. The fourth industrial revolution takes the automation of manufacturing processes to a new level by introducing customized and flexible mass production technologies. This means that machines will operate independently or cooperating with humans in creating a customer-oriented production field that constantly works on maintaining itself. The manufacturers will be able to communicate with computers rather than operate with them. All of this will be possible thanks to the artificial intelligence. So I think that it's important that to understand what is the meaning of the expression artificial intelligence. Probably all of us we have a common idea, but it is worth it to remind the definition from different point of views, as it will be help in understanding the actual concepts behind the expression. So in order to see what is different meanings of this expression, I checked the Oxford English Dictionary, where mentioned that the AI is the theory and development of computer systems able to perform tasks normally requiring human intelligence as perception, speech recognition, decision making, or translation between languages. And for example, for the most accessible source of basic information, as is the Wikipedia, AI is the intelligence demonstrated by machines in contrast to the natural intelligence displayed by humans. As we see, depending on the source, there are different nuances, different meanings. But if we try to take a common understanding, we can conclude on 4 key points that machines must fulfill to be considered as intelligent ones. To act and to reason as humans do, and even more important, to act and to reason rationally, because as we know, not all the humans reason and act rationally. So the next thing that we are going to check is if the artificial intelligence is a new concept. In order to check this, we need to try to check the history in order to see if there is in the past information regarding artificial intelligence. So in opposition to which it could be imagined, AI is not a modern concept. Putting aside the chess playing machine, the Turk, created by Wolfgang von Kempelen in 1769, at last it was acknowledged as a fake machine, we can state that the birth of the artificial intelligence happened in 1956, when during the Dartmouth conference, the proper term AI was conceived. And then it was intended to simulate the behavior of a human's nerve cell. Studies and investigation done by McCulloch and Pitt during that time marked the first steps in this field. Conclusion of that conference were very optimistic, as usual. In every conference, we have very optimistic point of views. The non-fulfillment of expectation in the following years derive in the abandonment of previous studies. These studies has advanced, moved forward hand by hand with available technology. In that moment, with information static and system tabulated, it could not be more progress. But when expert systems appeared in the decade of 1970, the matter dramatically changed and new machines were created applying AI. An important milestone in this development occurred in 1997, probably most of you remember, when a chess computer called Deep Blue defeated world champion Garry Kasparov by a score, if I do not remember wrongly, 3-1/2, 2-1/2.
Excuse me,
Yeah,
Rodrigo. I don't think
yeah,
your slides are advancing at the moment. We're still on Wolfgang von Kempelen.
yeah, yeah,
Oh, that's it.
yeah.
Okay, great. That's great. Sorry.
Perfect. Probably it was stuck. Thank you for the advice. Sometimes you can I can see, but never mind. So as I was mentioning, since 2005, it was observed a dramatic increase on computational capacity, which is reflected in a bigger capacity to comprehend, analyze the machines, and subsequently, artificial intelligence suffered a significant boom. Finally, I would like to answer the question if our industry is ready for the implementation of the AI. From my point of view, the answer is positive. The shipbuilding industry is increasingly embracing AI and related technologies to improve several aspects of ship design, construction, operation, and maintenance of the ships. While it may not be fully integrated in all shipyards of vessels, there has been notable progress in adopting the AI solutions. So in the next slide, I would like to show you different aspects where the AI can be useful. For example, some of the aspects where we can use in our industry is the design and engineering. So AI is used to optimize ship design and engineering processes. AI algorithms can analyze huge amount of data, including historical design data, performance metric, and environmental factor to suggest more efficient and innovative ship designs. Manufacturing and production, because AI-driven automation is being employed in shipyards to streamline manufacturing processes. Robots and AI-powered machines can perform repetitive tasks more efficiently, reducing production time and cost. Additionally, AI can be used for quality control, ensuring that ship components meet the required standards. AI-enabled condition monitoring systems can also analyze sensor data from various ship systems to predict maintenance needs and identify potential issues before to lead into failures. While fully autonomous ships might still be in the experimental phase, AI-based navigation systems are being tested and integrated into vessels. These systems can assist the human crews with route planning, collision avoidance, and many situational awareness, improving overall safety. AI can analyze real-time data from sensors on boards, including water conditions, fuel consumptions, and engine performance. To optimize vessel operations, we need to include or adjust navigation routes to avoid adverse weather and optimize speed or for fuel consumptions. AI-powered visual assistants or decision support systems can assist also crew members in making informed decisions during critical situations, such as emergencies or route planning. AI can also optimize shipping routes, container packing, or logistic operations, leading to more efficient use of shipping resources and reduced transportation cost. And finally, the AI can help vessels comply with environmental regulations by providing real-time emissions monitoring and suggesting strategies to reduce environmental impact. So, however, despite this advancement, there are still challenges to overcome, such as data privacy, cybersecurity, and regulatory concerns, especially about the implementation of the AI in autonomous shipping. The industry needs to address all these challenges while continue exploring the full potential of AI to bring more innovations and improvements to shipbuilding and maritime operations. So, what is the value of this digital transformation that we are mentioning here? So, I have put here some of the characteristics that lead us to the digital transformation: strategic, innovative, competitive, life cycle oriented. Here are some of the challenges, like, for example, legacy data systems, or people and process problems. We will check later on. But here we can see all the technologies that we are considering as part of this digital revolution. Internet of Things, you know, that is the extension of the internet connectivity into physical devices and everyday objects. The cloud computing is the ability of computer system resources, especially data storage and computing power, without direct active management by the user, allowing companies to avoid or minimize upfront IT infrastructure cost. The blockchain, digital record of transactions, the additive manufacturing is not necessary to mention, big data and analytics, virtual reality, augmented reality, robotics, that is the branch of engineering that involves the conception, design, manufacture, and operation of robots, cybersecurity, and obviously autonomous vehicles. All these technologies became the catalyst that allowed to develop the concept of the fourth industrial revolution, and therefore we can call them as the enable technologies. In our shipbuilding sector, in our maritime sector, the concept of the Industry 4.0 is commonly known as Shipyard 4.0, and this term designates the digital maritime supply chains from the concept to scrapping through all the different phases in design, construction, operation, and maintenance of the ships. We will check later on. In the next slide, I would like to mention what is the artificial intelligence. So this is just an explanation of myself. So here we can see that the AI is the combination of technologies in different stages of maturity, but is compounded by three different layers. The first layer is the basic AI. I have missed here to put the basic. Is the capability to enable computers to mimic human behavior. We have another layer that is the machine learning. In this case, the machine learning is the subset of AI which deals with the extraction of patterns from data sets. And finally, we have the deep learning, that is a specific class of machine learning algorithms that can use complex neural networks. In a sense, it's a group of related techniques comparable to a group of decision trees or support vector machines. Its components include artificial neural networks, convolutional neural networks, recursive, long short-term memory networks, and deepest beliefs, and many others. So inside all these capabilities, we can try to see why the artificial intelligence in shipbuilding is beneficial or maybe useful. So here I have stated, we can say like 4 of them, or in this case 5 of them. More complex projects, shorter delivery times, non-expert worker, more complex tools, and loss of know-how. So among the reasons that recommend the appliance of AI in maritime projects, most of them are common to other industries. Nevertheless, there are some reasons, this is the 5 ones that I have put here, more specific on shipbuilding industry. Ships or any other marine project are becoming more complex with demand of more technical specification, stricter national and international regulation, and with tighter budgets. At the same time, projects that they are more complex oblige to deliver in a shorter time. And this means that all phases are compressed, but without producing any reduction in the quality of the final product. The non-expert workers, here I'm going to explain, this fact common to all industries is even more important in the maritime sector, as shipyards, technical offices are obliged to involve into the development of project new staff with young and with no previous experience in ship design and shipbuilding people. This implies the adoption of non-optimized solutions or of solutions out of marine practice, with a negative impact with consequences not only in the construction, but also in the operation of the ships. Tools used in design, construction, and operation of ships are increasingly complex, trying to provide solutions to the objective of shorten delivery times at reduced cost. The use of such tools requires knowledge that is difficult and takes time to get it. Time doesn't exist according to project timing. We know all of this. So therefore, it is very convenient to count with a virtual assistant that guide the user and allow them not only to learn quickly, but also to solve problems without spending time in their analysis. And finally, the loss of know-how. I would like to mention that cyclic evolution of shipbuilding industry forces shipyards and technical offices to dispense with significant staff. These leaves rely mainly in elderly people with a lot of know-how that has the most relevant experience and expertise. The problem is not only in the loss of experience, but also in the lack of transmitting the know-how to the new generations. All these reasons and other more not explicitly mentioned here means important risk in the maritime projects, including the design phase that can be minimized with the use of artificial intelligence techniques. So I think that is worth it to identify the different ship design stages in order to see how the artificial intelligence can be used. All of us knows that the ship design processes involve several stages, each of which plays a crucial role in creating a safe, efficient, functional vessel. While specific terminologies and practices may vary or change among shipyards and designers in different countries, the typical stages in ship design are initial concept design, basic design, detailed design, production information, and maintenance and operation. Throughout the ship design stages, various stakeholders, including naval architects, marine engineers, structural engineers, electrical engineers, ship operators, must collaborate to ensure that the AI will help better and more reliable vessels and ocean structures which meet the owner's requirements, complies with relevant regulations and standards, and keep our environmental cleaner and our society safer. So once we establish the convenience of applying AI technology to marine projects, and we can say to their design phases, it is worth it to study how to integrate this technology can be in the process. To do that, I have prepared the next slide, where I have tried to explain how the AI contribute to the process of shipbuilding. I have separated in 4 different layers, 4 different pillars, where we can explain how to contribute into the process. The first layer is the efficiency, where we can count with user manuals, design guides, accessibility. Also, we have the reliability, where you know that a project is subject to contract specification, particular requirements, applicable regulations. So the AI can incorporate algorithms that integrate everything in the ongoing design, verifying the fulfillment of certain KPIs and making the task of designer more reliable and the project more consistent. We have also the experience. I have already mentioned the problems caused by the loss of the know-how and experience. AI can help in minimizing their effect, providing the designers with comparative and historical data, information from previous project, legacy data, or lesson learned. Everything with the objective of helping in facilitating prototyping of new ships and look into for the best alternative among existing ones. Finally, all the here above mentioned is compulsory, but is not sufficient, as the necessity for improving designs and shortening delivery times implies the optimization of processes. By means of the AI, the engineers can receive online recommendations and data for adopting best practices and for automating certain design tasks. Additionally to all of this, AI technology integrated in systems or design systems will enrich itself with data coming from current projects, making it a real-life project with self-learning capacity. So in order to analyze how we can see the improvement of the AI in shipbuilding industry, we cannot analyze as a whole, we need to analyze use cases. For this reason, in order to check the application of the AI, I have prepared 3 use cases for this lecture. So I have chosen 3 examples, one for each of the design phases, one for the design, another for production, and finally one for maintenance and operation. So regarding the design phase, one of the most complex aspects of the fitting design, as well as one of the most designer time consuming tasks, is the routing of distributors, could be pipes, ventilation ducts, cable trays on board. But not only this, the interaction of distributors with other elements as equipment, the restriction for routing, the fulfillment of regulations, the objective of optimizing design, fabrication, and assembly. So at the end, the application of AI techniques will assist the designer in taking decisions and adopting routines that optimize the design and minimize the design time. Among others, here in the slide, I have stated some aspects that should be considered as suitable for optimizing and automation. As regards production, I have chosen a practical case of mounting sequence of blocks. In the normal working method, structural blocks are assembled once they are finished and completely pre-outfitted, or to the level the shipyard considers acceptable, 75, 80%, 85% of the pre-outfitting. But in some cases, due to the lack of information from outfitting, to changes in the design and to material availability, blocks are not finished, but the overall schedule of the ship recommends to assembly without any delay. In order to detect these cases, and with the objective of reducing as much as possible the construction time, the application of AI can help the production manager to very quickly assemble the blocks and to mount missing elements, mainly from outfitting, into a further stage. So finally, as regards maintenance, I have chosen the practical case of operation. AI can also serve to optimize the third and the larger phase of the shipping process in the operational of the ship, considering available information and comparing it with parameters coming from other sources and making suggestions and taking decisions based in the best performance of the ship. Here in the slide, I have highlighted some of the cases where can be considered, as for example, data sensoring, performance monitoring. So, there are some examples of how we can apply this technology. So, there are many technologies using the principle of the AI. Some of the most relevant and increasingly popular are the automation, span automated tasks, for example, programs that execute tasks depending on inputs received, machine learning, including deep learning. It allows computers to act without programming, predicting behaviors or situations and proposing alternatives. Machine vision to give machines the ability of recognize images, natural language processing with the ability of understanding the human language, understanding intentions, robotics linked with automation but focus on machines more than on the software itself, self-driving vehicles, what we call autonomous vehicles, and finally, generative artificial intelligence, that it creates a variety of media from text prompts used for supporting programming, creating photorealistic contents, or email responses. So probably most of the people are very familiar with ChatGPT. So I would like to pay special attention to the evolution of language models. The evolution of the language models has revolutionized natural language processing, from chatbots to language translation and voice-activated platforms. Many of our lives have changed, and in this slide, I will explain the most popular ones. We have the probabilistic models. N-gram language model is a probabilistic model for predicting the next item in a sequence. We have also neural network-based language model. That is a recurrent neural network language model. Is basically a neural network containing one or more recurrent connections. A transformer, that is a neural network architecture developed at Google that relies on self-attention mechanisms without relying on convolutional or recurrent neural networks. And finally, the famous generative pre-trained transformers, GPT, are a type of a large language model and a prominent framework from generative AI. The first GPT was released on June 2018 and contained around 117 million parameters. Here, when I talk about million, billions are American ones. GPT-2 was released in February 2019 and contained around 1.5 billion of parameters. GPT-3 was released in May 2020 and contained around 175 billion of parameters. And finally, we have the ChatGPT-4 that was released last year in March, and they mentioned that it's undisclosed. However, there are experts that mention that we have reached 1.75 trillion of parameters. Okay, so back to the AI in shipbuilding, I would like to place here an example of an AI solution. I have tried to avoid any commercialism, so I have created this slide where I have put here the engineer, the lady who is going to work with smartphones, tablets, or PC. So I would like to propose a solution architecture where the core of the architecture is composed of the corpus of data and the application serving the AI application. So the data contains all the data used by the algorithms to provide the answers to the questions and searches of an end user. AI uses all this data to form the answers to the user. Communication of user with AI makes use of the most modern ways of communication. AI use LLM, large language models, for the better understanding of users focused in the data that serves to business. AI algorithms use the models to select the most accurate responses, considering not only the words, but also the context and the big hitters from previous answers. And with all this, it is possible to refine the models, enabling the growth of AI in the field of interest. So AI system can be seen composed of three sets of applications: understanding the user, selecting the most accurate responses, and finally learning from the satisfaction of the users with the answer for improving future answers. Company users may keep updated both data and algorithms and will qualify the models when the information request is adequate for the purposes sought. So I want to finalize the presentation with two slides. One is how the AI can be used in the CAD/CAM industry. This is super simple example. We can use as analyze tool, show me how to do a task, provide me guidance on how I need to locate this pipe, or how can I navigate through the data in a product lifecycle management program. In the generation, create a model of, create a block of a container ship, make optimized hull forms from supply vessels, perform multi-domain tasks, and create engineering content. And finally, the optimization, which options solve this, which optimized product can fit better, or the balance trade-off. And the other slide that I would like to mention is how is our concept of the fear of the AI, or if the fear of the AI is overblown. So in this slide, I wanted to show you that the AI is not entirely overblown, as there are legitimate concerns and potential risks associated with the rapid advancement of the AI technologies. It's important to note that not all concerns about AI are entirely justified or well founded. Some fears may be based on misconceptions, sensationalized media reports, or science fiction portraits of AI. Furthermore, many experts argue that the potential benefit of the AI outweigh the risk if appropriate measures are taken to address the challenges. To mitigate the risk associated with AI, it is essential to have a robust regulations, standards, and ethical frameworks governing the AI development and usage. Additionally, responsible AI research and development that prioritize transparency, fairness, and accountability can help address many of the concerns associated with the AI. So, rather than dismissing all fears about AI as overblown, it is more productive to engage in informed discussions and collaborate to develop AI in a way that maximizes its benefits while minimizing potential risk and negative consequences. Striking the right balance will be crucial in shaping a future where AI technology is used for the betterment of the humanity. So there is another area where the future generation, the younger generation, is more alarmed, is the loss of positions. In the next slide, I'm going to explain, but I would like to highlight, for example, this picture where we can see in a news from 1988, math teacher protests against calculator use. Always that we have a new technology implementation, always there is certain fear about this technology or this new technology. So, as I mentioned, while AI has made significant strides and shows great promise in certain applications, it is still far from replicating the full breadth and depth of the human intelligence. AI and human intelligence have distinct strengths and weaknesses, and their collaboration offers immense potential, a huge potential for addressing complex challenges and improving several aspects of the human life. However, it is crucial to navigate the development and integration of AI responsibility, considering its potential impact on society, ethics, and human well-being. In other words, we need to mitigate some of the AI concerns. I have thought in 5 concerns. Job displacement is one of the primary concerns that the AI and automation could lead to significant job displacement in various industries. As AI becomes more capable of performing tasks that were traditionally done by humans, there are fears that it could result in unemployment and economic inequality. Even this, taking into consideration some studies like the ones that I place on the left of the presentation, entitled The Future of Employment, or How Susceptible Are Jobs to Computerization by Carl Benedict and Michael Osborne, examines expected impact on future computerization on US labor market outcomes with the primary objective of analyzing the number of jobs and risk. In this report, the author stated that naval architects and marine engineers is one of the professions which will be less affected by the implementation of all this computation or technology. AI systems are trained on data, and if that data contains biases, the AI can perpetuate and amplify those biases. This could lead to unfair and discriminatory outcomes and in several areas such as hiring, lending, or law enforcement. Also, the development of AI-powered autonomous weapons raised ethical concerns about the potential for these weapons to act independently and make life and death decisions without human intervention. AI systems handling sensitive data could be vulnerable to cyber attacks, leading to privacy breaches and other security issues. And finally, there is a concern that the AI, or as AI systems became more sophisticated, they might become challenging to control or to regulate, potentially leading to unintended consequences. So AI is not a matter of science fiction. This is something that we have seen during the presentation. So I would like to mention some of the conclusions. The first one is like the AI is a fundamental enabling technology for shipbuilding. It can be used, but we need to be very careful about in which aspects we are going to use this AI and can be more benefit. In other words, is one of the enabled technologies that is going to have most change the current ship design and have more direct impact in the development of the concept of the shipyard 4.0. AI in shipbuilding is currently in development process. However, its potential is huge in all aspects of the production chain. AI can be adopted in every phase, design, construction, and operation life cycle. As AI learns from previous cases, designs, it is essential to have reliable and correct data that creates the corpus that the algorithms of AI check to suggest solutions and even to take decisions. The AI needs to be fed with data each time, allowing it to learn and refine its application. Right now, when we implement AI, it's like a baby. We need to teach the software in order to provide better decisions. And finally, the AI implies the participation of experts. The collaboration of the best is the most secure guarantee for successful implementation. Stakeholders must involve in the development of the systems the best AI experts whose experience obtained in other industries is almost in full applicable to our industry. And finally, the last slide is, it's like an optimal vision of the AI. Nowadays, it is unimaginable to work without using digital tools in shipbuilding. CAD, CAMs, simulation tools, PLMs, easy of design with design rules embed, speed of design, use and reuse of information. It's expected that in the future, these tools, these softwares will advance further and allow greater information management through the AI. There are several scenarios of improvements explained during this presentation, during this lecture for the next years. Some of these improvements may be or may seem unrealistic in the short term, but reality often exceeds expectation in any field and probably more in technology. So finally, I would like to transmit an optimistic vision of the future of our industry. And do not forget what is the most important is to motivate our teams, our colleagues, and our students in one of the most extraordinary professions. For this reason, I bring into your attention a quote from the author of The Little Prince. It means that before to start to implement any new technology like the AI, we need to share our vision and show them what is the final product that we want to deliver.